So I have a very swooshy audience response system that's not going to work. So we're going to ignore that part. Here's the first part about Zoom. I have no disclosures whatsoever. And here is the title of my talk. Nearly everything you learned about race in medical school is wrong. Now, we're not going to be able to do this. I do a poll, and I have some statements. And since we can't do the audience response system, I'm going to read a couple of statements. And I would encourage you to close your eyes. And if you agree with a statement, put your hand up way high. If you think, yeah, maybe, or I'm unsure, here. And don't raise your hand at all if you don't agree at all. So this is Audience Response System 101. So this is a sentence that we're taking to be your beliefs about modern humans. So not Neanderthals, but all of us walking around here. And the statement is, a person's race can be determined simply by looking at their genetic makeup, their DNA. So I don't know, I have a little tube of DNA, and I'm going to do all sorts of cool molecular things. And based on that, can I look at that and say, this person is African American, this person is Asian American? So if you agree with that statement, put your hand up high. If you're, I'm not sure, put it halfway. And if you don't agree at all, keep your hand down. OK, good. It's a good start. The next one is, in the absence of genetic information, race is the best alternative doctors have to identify genetic determinants of health. So this means that I have a patient in front of me, and they say, Doc, what am I at risk for? And I look at them and I think, well, you know, I don't have their genotype, but based on their race, and it can be their self-described race, this is what you're at risk for. So if you agree that race is the best alternative when you're trying to identify genetic determinants of health, raise your hand up high. If you're like, sometimes yes, maybe sometimes no, midway, and strongly disagree, just keep your hands by your side. All right, pretty representative. And our last statement is, race is important in health research due to its genetic relevance. So put your hand up high if you're like, yes, we need to consider this when we are doing our health research. If you're like, well, sometimes yes, sometimes no, put it midway. And if you're like, no, it's never important because of its genetic relevance, leave your hand down. OK, we've got some room to work with. So you can put away your audience response systems now. All right, so over the next 45 minutes or so, I'm going to discuss the impact of systemic racism in health professions curricula. I'm going to compare and contrast biological and socially defined race, evaluate disparities in the pathophysiology of disease, and end up with an approach to how we can address health disparities in healthcare education. So the first question, and one that most of us didn't really ask, was how does race show up in the curriculum? I'm a pathologist, and as Dr. Reddy said, this was my book. I was teaching using the 10th edition of Robbins. And I wanted to get an idea of the extent of race-based medicine in our textbook. So in order to look at this, I took the electronic textbook, and I used terms like Caucasian and African and Hispanic to see what was in there. And I found more than 35 diseases with some sort of racial disparity, either prognosis, incidence, prevalence. Now, let's take a look at how some of these showed up in the textbook. These are 4 direct quotes from the 10th edition of Robbins, linking African Americans and cardiac amyloidosis. We have cystic fibrosis in Caucasians, cholesterol gallstones in Native Americans, and EGFR mutations in a subset of pulmonary adenocarcinomas in whites and Asians. Now let's set aside the outdated terminology for starters, right? Because we should be able to, just find and replace. So we don't need to think too hard about that. And let's recognize that when these sentences were written, they were written with good intentions, with the belief that these epidemiologic data would help future physicians to develop a broad yet focused differential diagnosis, to order and interpret appropriate laboratory tests, and ultimately to provide optimal patient care. So these were written with good intentions. But I think we all know that you can't just say, well, I had good intentions. We have to actually ask, are we causing harm? So are we causing harm? I think we are. And there are 3 areas we're going to look at. The first of these is something that I call buzzword bingo. We take very bright, very motivated medical students, and we teach them simple word associations. White, cystic fibrosis; black, sickle cell disease. And we reinforce this with our clinical vignettes, with our quiz questions, our exam questions, our board prep materials, and the boards themselves. Now, let's take a look at some of this board prep material. This comes from the website crashingresident.com from 2015. And this is advice to help students prepare to take step one. And one piece of advice is be as racist as possible. Now, as you look at this, you may be feeling humor, discomfort, anger, frustration, but you're probably also feeling a sense of recognition, like, oh yeah, I learned that. Black people get sarcoids, sickle cell, keloids, high blood pressure, right? That's what I learned when I was taking my boards, and this is what we see here. Now, this is not particularly scientific. It's written for humor. Let's look at something a bit more academic. This comes from a study from 2017 by Rip and Braun. Now, they wanted to look at how race and ethnicity were used in board exams, but you just can't call up the NBME and ask for those questions. So they did the next best thing. They looked at the step one question bank for UWorld. So UWorld is a test prep resource that is the most widely used worldwide. About 250,000 health profession students access it every year. So this is not a small niche product. What the researchers did was they looked to see how often race and ethnicity were mentioned, and they further categorized these as to whether it was descriptive, the person just happened to be white or black, or whether it was central, that knowing that person's race or ethnicity was critical if you were going to get the right answer. Now you can see their data here. Now, out of about 2,100 questions, 20.6% mentioned race or ethnicity. Now, if we look here at the group white/Caucasian, you can see about 93% of the time the person just happened to be white. Had nothing to do with getting the right answer, and about 7% of the time you had to know that. All right, so 7% of the time it's critical. So it's probably something like cystic fibrosis. Okay. Now, when we look at this, you can see that 407 of the total mentions was white/Caucasian. So that's 86% of the time race or ethnicity is mentioned. Now, if we consider, using 2020 census data, what the proportion is in America, you can see that this is vastly overrepresented. This is something that can be referred to as centering whiteness. This is the norm. Everybody's white. Now, while that's problematic, what's even more egregious is that when we look at the Native American area, first of all, very rarely does a Native American show up on your board question. But if they do, they're there because they have a Native American disease. They're not there because they were bitten by a dog or in a car accident. They have something that Native Americans get, like gallstones or severe combined immunodeficiency. So you may be saying, all right, Dayrep, you're getting all exercised about nothing, right? This is just the preclinical years, and when our students get on the wards and then they become residents and attendings, they're going to learn that any person can get any disease, right? Well, there are things I learned 20 years ago at the University of Chicago from Robbins that I didn't learn were false, were wrong, until I started really looking at race in medicine. So I think it's worth looking at. Now, the second question, of course, is, are we causing patient harm, right? First, do no harm. This is our mandate. And again, yeah, I think we are. So a young Navajo woman presents to an acute care clinic. She's got right upper quadrant pain. And the young attendant is like, Native American, it's got to be gallstones, right? Just fresh from taking boards. What about acute appendicitis or an ectopic pregnancy, either of which could kill the patient? Now, again, you're saying, Dayrep, calm down. We got this. We got algorithms. We got checks and balances. This isn't going to happen. So here is a report from the literature. The author is talking about a childhood friend who was only diagnosed with cystic fibrosis at the age of 8. Now, most kids are diagnosed before the age of 1 month, which is critical for them to get the care they need for longevity and better health. This kid presented multiple times with suspicious symptoms, again and again, and was only diagnosed correctly by a radiologist who literally could not see that she had darkly melanated skin, who looked at the chest x-ray and say, hey, who's the kid with cystic fibrosis? Because we have blinders on and we see what we expect to see. So yes, I do think we are causing patient harm. Now finally, as long as we're looking, we have to look with a really wide view. Is there a way that we are causing harm in our society? Is there a way that we are elevating one population up and pushing another one down, saying, bad genes, risky behavior, non-compliant? Is there a way we are subtly or not so subtly setting up a hierarchy? So to make that easy for you to visualize, I'm going to redline for you the diseases in the 10th edition of Robbins that were listed as being more common or having a worse prognosis in African Americans or people of African descent. And for comparison, let's look at European Americans and European descent. So yes, I think there is a focus here where we are setting up hierarchy. So we're talking about race. So we have to step back and say, what is race? So in modern biology, races are defined by two criteria: the amount of genetic variation within and between groups, and phylogenetic evidence of a unique lineage. Now, other species do have races, but modern humans do not. And we have known for a very, very long time that there's more variability within so-called races than between them. Now, obviously, we have geographically based genetic and physical differences. You can look around the room. And part of the intellectual trap for us is when we look and we can say, that person is Asian, I can tell by the outside, they must also be different on the inside. And what we know from science is that biologically that's not true. So biological race does not exist in modern humans, but we know, and as I was discussing with the residents, socially constructed or socially defined race absolutely does. And this is the arbitrary use of aspects of appearance, geography, culture, etc. But this is in the service of a social dominance hierarchy. It's not like there were a lot of people sitting around saying, hey, you look different, and you look different, so we're different groups. It was like, you look different, you're down, I look different, I'm up. So this is intentional about setting up a hierarchy. Now, people are learning that modern humans do not have biological races, and they can say that. And we're seeing this scientifically. This comes from a book on epidemiology. This is the introduction, where the author is very upfront. Race is a socially constructed variable based on the idea that some human populations are distinct from others according to external physical characteristics or places of origin. And he goes on to say that racial or ethnic variation in health-related states or events are explained primarily by exposure or vulnerability to behavioral, psychosocial, material, or environmental risk factors and resources, not biology, not genetics. So how do we classify races in this country? This is the brand new 2024 OMB Statistical Directive 15. So this may be new to some of you who are used to there being 5 races and with ethnicity being a separate question. So we can see here we have American Indian, Alaska Native. That's the original peoples of North, Central, and South America. We have Asian, Central East Asia, Southeast Asia, South Asia, Black or African American, the Black racial groups of Africa. And then they've moved the ethnicity of Hispanic or Latino up to this question because there was confusion around it. We'll have to see whether this improves matters or worsens them. Middle Eastern or North African is also a new addition in 2024. You'll see it on your next census, as well as your tumor boards and your NIH grant applications. And then you have white, original peoples of Europe. So this social classification is used in all federal applications. And so these are the things that we will see. Now, one problem with this is that one of the immediate questions is, well, how much does it take of any one of these for me to be one thing or the other? They now say select all that apply. Now, I'm half Chinese, half European, and I would often arbitrarily just pick whichever race I felt like that day when I was checking into Duke or doing something else. But now I get to put both. But when we look, for example, at African Americans who on average have 16% European ancestry, does that mean that we all put in I'm European as well, or I'm white as well as black? How do we define this? And this is a social classification. And this will have impact on people doing research on biological specimens. So since we're talking about race, it looks like we're talking about geography, so let's look at a map. So this is a map showing the distribution of a variety of hemoglobinopathies. So we have thalassemia in green, hemoglobin S in orange. Now, we all know that hemoglobinopathies are prevalent in human populations because they confer a survival advantage in the context of malaria. So one thing we can say by looking at this map is it's showing us the historic or ancestral or even current distribution of malaria. And one of the things you can appreciate is that this is not respecting political boundaries. It's not like we see it just in India or just in China. We see it in parts of China and other parts not so much. And you can also see that the distribution it varies quite widely, and there are areas where we don't see these hemoglobinopathies. Now, I think what really brings home the fact that this is a pathogen geographic effect is if we look at this white area in the north of Africa. Now, you may think, look at that, there are no hemoglobinopathies. Who are these people that don't need any sort of defense against malaria? They must be amazing. Well, actually, that's where the Sahara Desert is. No water, no mosquitoes, no malaria, no hemoglobinopathies. And there's some other subtle differences here, which I'm not going to go into unless it comes up in the questions, but we'll get to that in a moment. Now, let's look particularly here at Africa. And you can see the distribution. We often think of hemoglobin S as the African-American disease, but in that previous slide, you could see we do have it in sub-Saharan Africa as well as Southern Europe, parts of the Middle East, and India. Now, as we look at this map, if we were to compare it to a map showing the origin of enslaved peoples in our country's history, even knowing nothing about modern America, you would probably say, well, I'll bet we got a little bit of hemoglobin C and a fair amount of hemoglobin S. And you would be right. So this is just one study from Howard University, a sickle cell screening clinic. And you can see that the vast majority have wild-type hemoglobin A, and about 10% have at least one hemoglobin S allele, and there's a smaller number of people with a hemoglobin C allele. Now, you may be thinking, okay, I can start making, maybe I can't tell by looking at someone's appearance, but if I bring in some knowledge of their ancestry, maybe then I can predict whether they're going to have sickle cell or not. Well, you have to be careful with that. So if we look at sickle cell trait in the United States, it's about 8 to 10%. But if it's someone who's from Africa, it is up to 15 to 28%. And that's because of ongoing pressure from malaria. Now, this becomes important when you look at a patient or trying to quickly ascertain what their risk is, when we consider that a rising share of the US Black population is foreign-born, and they can come from parts of Africa that have no risk whatsoever for hemoglobin S. Now, things get even more complicated here when we start talking about population admixture. So this is looking at ancestry informative markers in people who self-describe as African American. On the left, we have mean African ancestry in blue, and on the right, mean European ancestry in red. And you can see there's tremendous variation. If we look at the state of South Carolina, there is almost no European ancestry, whereas West Virginia is more than 30%. And we also see high amounts of European ancestry in Washington State as well as Kansas. Now, things get more complicated when we look at Latin Americans. So this is because there is a triadmixture of European, African, and Native American. And again, you can see there's tremendous variation across the country. So we can't just say as part of our descriptor in our biorepository, oh, this person's Hispanic, right? That doesn't tell you anything about their ancestry. Now let's take a look with a bigger picture. Let's look beyond the United States. So this is looking at the genetic ancestry of Latin American populations, using again these 3 continental ancestry groups, Amerindian, European, and Sub-Saharan. Now, if you look at Puerto Rico, you can see that it's about 72% European, 16% Amerindian, and 12% Sub-Saharan African. As we look further, we can see Mexico has a much stronger contribution from Amerindian, a smaller amount from Sub-Saharan Africa. Peru has a very strong contribution of Amerindian, very minor component of Sub-Saharan African. And when we look at Colombia, we can see it's got sort of in the middle, 64% European, 29% Amerindian, and just 7% Sub-Saharan African. Now, if you're looking at this, you may think, oh, look how different these various areas are. We could do some really cool things looking, for example, maybe at brain tumors in these various regions and figure out what the ancestry has to do with it. But you have to stop. You have to be very careful about your data. So let's cone down just on Colombia. So admixture is going to depend on your history. So these two images on the left are showing maps of the genetic ancestry of individuals, and each line represents a single individual. So I'm going to try to move the mouse. Oh, it doesn't matter. Never mind. So if you look at the line on the far right in Choco, it's almost entirely sub-Saharan African. This individual has a small component of European and an even smaller amount of Native American. Now, in this study, they looked at the urban center of Medellin, which showed a distribution very similar to the rest of the country, primarily European, also Native American, and a small amount of African. But if you look in this coastal region of Choco, what you see, it works out to be about 76% African ancestry. So why is this? This was an area of gold mining, and so enslaved people were brought here to mine. In addition, it's a jungle area, and so enslaved people who were trying to escape their bonds would try to escape to Choco so they could find relative safety. So you can see that when we really look at the data, we can't make sweeping generalizations at the country or even a regional level. So race is not a biologically useful construct. I hope that we're all on that same page. So why are there racial disparities in health and disease? Right, there's got to be some reason. Well, you guys already know the answer, but we'll work through it. So we know there are differences. We see maternal deaths on the left. This is a shocking, absolute catastrophe in this country when we look at deaths in African Americans and American Indians, Alaska Natives. And we see this reflected in premature births as well. For every type of malignancy we look at, we are going to see higher death rates in African Americans compared to other groups. So we have cancer of the colon and rectum on the left, with the top red line is what they call black males, black is white males, then we have blue is black females, and green is white females. And on the right, cancer is the corpus and uterus, with black females showing a higher death rate than white females. So clearly there are differences. We're not going to pretend like there aren't. We have to recognize that. So what causes disparities? Well, we can think of, and what we've mostly been taught back before we learned about other things, was it's intrinsic, right? They're genetically different, biologically different. So let's look at some of these. Well, we do know that we can have genetic differences based on a selective advantage. So those were the hemoglobinopathies I showed you. But as you now know, or as you were aware then, what determines that prevalence is going to be geography. Was there this pathogen? Could it grow in this area or could it not? So that's geography, not race. We've got founder effects or population bottlenecks. We also have genetic drift. So a population bottleneck would be, for example, the increased incidence of severe combined immunodeficiency in the Jicarilla Apache and the Navajo. This is because of the genocide earlier in our country's history. Now, it's not all Native Americans, it's not that race, it is this small subpopulation of that. So again, population, not race. And then finally, we can have endogamy. So this means marriage within, but we're all scientists, so what we really mean is breeding within our particular group. Now that can be based on religion or caste or geography, but it's not based on race. Now, the contribution of these intrinsic causes is incredibly minimal. Okay, and this is a quote from the New England Journal of Medicine from 2003. I use this older quote to emphasize that this has been known for a long time. And in fact, biological anthropologists and evolutionary biologists have known this since the time pretty much of Darwin. So the central observations remain. Genetic variation is continuous and discordant with race. Systematic variation according to continent is very limited. And there is no evidence that the units of interest for medical genetics correspond to what we call races. And yet, as scientists, as clinicians, we have spent so much time, energy, and money looking at allelic differences based on socially defined race. There are entire careers that have been based on this, grant applications. So if it's not these intrinsic causes, what is accounting for these maternal deaths, these fetal deaths, these increased death rates from cancer? Well, we all know it's something that's referred to as the social determinants of health or the extrinsic causes. And these overwhelmingly are what account for these disparities, and they tend to be linked. So poverty will be associated with lack of access to care, to living conditions with toxin exposure, to lack of nutritious food. All of these are also affected by individual, institutional, and systemic racism. Now, one of the things I recommend for students and colleagues and trainees is that whenever you see something is more common or worse in a particular socially defined race, is you ask why. And these extrinsic causes are a good place to start. So here's just one example. This is a quote from Up to Date based on the 2 studies referenced below. Now, as you're aware, when it comes time for hysterectomy, there can either be an open incision through the abdomen, which has significant morbidity. You can't lift heavy objects. It takes a long time to recover. Or you can have a minimally invasive technique, and that can be a robotic assist, transvaginal, laparoscopic. And what these 2 studies showed, that if a person was eligible for either type, if that person was Black, Hispanic, or publicly insured, they were much less likely to get a minimally invasive technique than a white woman. Now, we would say that the factors here would be systemic racism because of the link to public insurance, institutional racism because the hospitals that served these populations had fewer surgeons trained in minimally invasive techniques, and then poverty, education, access to care, health insurance, all of these. Now, this is a quote from the 10th edition of Robbins talking about the pathologic effects of high blood pressure in African Americans. And what we would say here is that all of these contribute. There is no slavery gene, regardless of what Oprah Winfrey and Dr. Oz have said. All of these are contributing to this, and we have to be aware of that as scientists and clinicians. So now that we've recognized there's a problem, what do we do next? So we have, I'm going to address each of these: terminology, team building, and then where I spend most of my time is in the thoughtful, mindful analysis of the material driven by data, inclusivity, and context. So about terminology. This is what we did for Robbins, okay? We removed all the archaic anthropological terms like Caucasian, which is a pseudo-scientific term which has been used in white supremacy, or as Edwin Lind would say, the white oligarchy. Caucasian is used at the same time as Mongolian for Asians and Ethiopian for Africans. So clearly, if we're not using Mongolian and Ethiopian, we can also dispense with Caucasian. We also decided not to use skin pigmentation in the book. So we wouldn't say this is more common in whites or in blacks. Why do we do that? Well, for one thing, it sets up a false dichotomy. And in one of the research papers that I did, we looked at the American Academy of Pediatrics textbook and frequently be like, it's this in whites and this in blacks. Well, what about the rest of us? So if we're going to use terms like white and black, does that mean everybody else is yellow, brown, and red? That's not good. We don't want to go there. So let's just avoid using white and black. I also think that we have associations at the conscious and subconscious level of white being innocence and purity and black being bad and evil. So we just don't need this. So we didn't use that either. We elected to use ancestry and socially defined race. So we use ancestry for our single gene diseases, which are quite rare. And when we do this, we're going to use European descent, African descent. But we're very careful in the book to emphasize the conditions that cause that. So we're going to talk about malaria when we're talking about G6PD, sickle cell, et cetera. And we use socially defined race when we're talking about our complex diseases, which have a genes times environment interaction. And this is most of what we deal with. This is American health: diabetes, hypertension, cancer. So this was what we opted to do in the textbook. And this is what I think is important for scientific discourse. When we're talking amongst ourselves, we might refer to issues for white people, black people, brown people. But in scientific discourse, I think we need to be very clear because it is so easy to conflate biological race and socially defined race. So just a word about ethnicity. So in the United States, we primarily dichotomize ethnicity as Hispanic, non-Hispanic. This is a bit problematic as well. So I already showed you the genetic ancestry maps where we recognize that there is no homogeneous Hispanic population. And furthermore, the word Hispanic is going to refer to populations that speak Spanish. So that's going to exclude our Latin American countries like Brazil, Guyana, and Suriname, and that'll bring our friends over from the European continent of Spain. So that doesn't make sense because we're talking very different social contexts. So there are other terms that are used. Spanish is a gendered language, so you have Latino, Latina. There's been a move to Latine, which is gender neutral, or Latinx. These terms are in flux. So in the textbook, we elected to refer to individuals from Latin America to reflect that. Again, not perfect, but a step in the right direction, I hope. So when you're thinking about terminology, I highly recommend that everyone pick up a copy of this National Academies of Sciences, Engineering, and Medicine publication. came out in 2023, using population descriptors in genetics and genomics research. So this is a 215-page publication. It's got a lot of good things. It's got decision trees. And if that's too much, I do have a YouTube video where I go over the salient points. So I'll link you to that later. You may recognize some faces here. So I was talking with the residents about the importance of building a team. So I see very clearly with my eyes, and I feel very well with my skin. But I cannot see what many, many other people experience. And I can't learn about that unless I connect with them and have humility and I empower them to share their opinions with me. You can see Dr. Upton, Dr. Jackson, and I was talking with someone, that's Dr. Tema Okun in the bottom right. So it's very important that you get as wide and diverse a group as possible. Please bring in the students and trainees, right? They are far ahead of us. Particularly when I look at some of our older attendings who were steeped in the tea of race-based medicine for decades. So when I was working on the 11th edition of Robbins, I put up an anonymous Google Doc so my students could reach out to me. Duke students are not shy, so they just would email me. But part of this is also the importance of asking to be called in. Please let me know what you see. Because if I ask for that, then the feedback is given in that spirit, not, hey, Dayrup, there was something racist here, but hey, Dayrup, I think you might have missed something, and this is my take on it. Thank you very much. So I'm really into data. I really want to know. And when I got those 35 diseases that showed these disparities, I wanted to understand. So I did a deep dive into every single one of them. I have about a 90-page document with figures and references that I'm happy to share with anyone. I can send it to Dr. Reddy, and you're welcome to share it widely. So because of that, one of the reasons I did this was for my medical students. I couldn't say, hey guys, sorry we have a lot of racialized medicine in the textbook, but next year's group will have a better chance, bye. I wanted to show them what the truth is. But I also needed these data so I could challenge the other Robbins editors about why we needed to make these changes. So when the editor sent me his chapter and it had this quote in it, certain individuals seem to be predisposed to keloid formation, particularly those of African descent, I said, I'd remove this. And his short reply was, this is what it says and up to date. And I was like, okay, well, that's not my reference of choice, but thank you. And I'd already read up to date, and I'd even read reference 5. And I go into this in great detail on a 21-minute video, which is just on keloids, which I'm also happy to share. So 16%, that's a really specific number. That sounds like someone did some good research there. And we see it everywhere. We see it in StatPearls 2021, Medscape 2021, Textbook on Scar Management 2020, California Department of Public Health 2022, which has been inclusive by including Africans, Hispanics, and Asians. So they get included in that 16%. So where did the 16% come from? So it was very hard to find, but I found it. Here it is. It's from the 17th of May, 1931. Now, this is, it's in French, so if you're struggling, it's not your eyes. And these are the reports of the proceedings of a dermatologic meeting in Strasbourg, France, in 1931. Now, at that meeting, a fellow named Monsieur Lespin from Brussels got up and gave a talk about tattoos and keloids in Negroes of the Congo. And when he finished, Monsieur Stahl, instead of asking a question, as so often happens at scientific meetings, presented his own research. And he said, I really enjoyed what you said. Let me tell you what I found when I was in the Congo. What I did was I looked at 1,205 adult black workers. Now, and he looked at them for keloids. Now let's just pause and acknowledge the colonial exploitation. Hey, you 1,205 black adult workers, get here, take off your clothes, I'm gonna look for keloids, okay? What he found, as he was done, was that 16% of them had keloids. So you can say, based on this research, that adult males in the early part of the 20th century in this particular area of the Congo have keloids. But you certainly can't say all Africans have a 16% risk, or everyone of African descent, or even expand it to Hispanics and Asians, right? So that's problematic. But what I find even more egregious is that on that very same day, at that very same meeting, someone else gave a talk. This was Professor Nagley from Bern, Switzerland. Now, he also really liked keloid research, but he did not have a research outpost in the Congo. So he just looked around at Swiss people. He looked at adults and he looked at kids. And these are Europeans. And what Professor Nagley found was that 13.3% of them had keloids. Now, the numbers are high because of smallpox vaccination. So that's why this is historically quite high. Now, this is maybe statistically significant, but it certainly is clinically absolutely irrelevant, right? I mean, you're not going to say, well, we're not going to do this because there's, this tiny difference. We need to categorize you based on race because of this tiny difference. So why is it that the 16% has come down 90 years and the 13.3% has not? Well, you can watch this video and you'll learn more. All right. Now, if you have a data-based approach, as soon as you say, like, here are the data, you're going to hear, but what about? And so when Dr. Graves and I wrote a New England Journal of Medicine perspectives like that, there was a letter that was arguing with us. Now, the letter had fatal flaws, so it was not published. But we did look at the references that they mentioned, and you can see them here. In the first study, we're looking at 429 patients, where we see a 7.1% keloid incidence in African Americans, 0.5% what they call whites. And then we have another study, much larger, which shows 0.8% in African Americans and 0.1% in whites. Now we add in our 16% and our 13.3%, and our numbers are all over the map. So what accounts for this? You cannot talk about specific populations if the populations themselves are not specific. Now, I'll also add that when you use data, you have to keep in mind that much of the literature is scientifically corrupt and was printed, published, designed in a time when there was a very strong belief in biological race. And if you look at the weight of that literature, you will find that there are differences. And this is because our social conditions affect our biology, exposure to toxins, stress, et cetera. So it's very difficult, and you have to be aware that you will get pushback using the literature. So inclusivity is very important. I'm sure you're looking at this and you're busily diagnosing the various diseases, but some of you are saying, wait, there are no trees in this forest. To make it easier to see, here are 3 of the very few images in the 10th edition that showed lesions in skin of color, including, of course, the ubiquitous keloids. So for the 11th edition, we show multiple images with different skin types. And I think this is very helpful because if we don't show this to our students, how can they ever diagnose it? We also fixed the text. On the far right, you can see the classic salmon pink plaques with silvery scale of psoriasis. Below, we have an image that shows the hyperpigmented plaques and gray scale that you see in darker skin types. Also, I find particularly useful on the far left, you see a basal cell carcinoma, typically described as a pearly papule. Not in everybody's skin type. I think the one on the right, which is a basal cell carcinoma in darker skin, looks to me a lot like a melanoma. It's ulcerated, variation in color, irregular border. If we don't teach this, no one will know. I don't think this needs much discussion. This is the 10th edition. It took a surprising amount of effort to convince the other editors that having everyone be a light peach was not ideal. So now we just show the skin, the paper below. And then we want to use appropriate terminology throughout the text. So in the 10th edition, it refers to factor V Leiden and whites. Now we know this is a genetic disease, so we're going to use genetic ancestry. So we use here, we refer to European ancestry, but we don't want this to be like find and replace for medical students. Where it says European ancestry, they mean white. We want to emphasize, because of population admixture, that anyone can have this. This is particularly important for this disease because as we are particularly concerned about homozygotes for factor V Leiden, but your heterozygotes have thrombophilia as well. And you cannot tell by looking at someone what their ancestry is. So is it true that nearly everything you learned about race in medical school is wrong? Well, biological race does not exist in modern humans. But we're not advocating we go to this colorblind or race-blind approach. We know that socially defined race has a huge impact on health. I discussed this with the residents. So we don't want to be like, oh, it's not there. We want to recognize the context that this patient is bringing, their exposure to toxins, to stress, to hair care products, for example. This can be referred to as race-conscious medicine. All right, now we're going to go up to my fabulous poll, which we can't do because it didn't work. So I'm going to ask again, and I'm sorry for you in Zoom land. You can do this on your own. But I'm going to read again 3 questions, and put your hand way up if you're like, yes, I totally agree. Middle if you're like, I'm still not convinced, and just leave your hand down if you disagree. So this statement is going to be, and this is about modern humans, a person's race can be determined simply by looking at their genetic makeup, their DNA. So again, you've got that tube of DNA, and someone says, hey, is that a black guy or a white guy? You're like, just a second, put it in the machine. Hands up, down, neutral. All right. Next, in the absence of genetic information, race is your best alternative that doctors have to identify genetic determinants of health. So family comes in and they say, here's our little boy. What is he at risk for? What genetic diseases could he have? So is race the best thing you can use for that person's genetic risk? So again, high up if you're like, yes, indeed, or yeah, not so much, or mm-mm. Oh, you guys are so good. Finally, race is important in health research due to its genetic relevance. Like, this is why we write these grants, because we need to look at the allelic frequencies in these various races so we can know why prostate cancer is more aggressive in African Americans than European Americans. So again, high up, you're like, yes, I totally agree. And I understand that there's like a whole lot of pressure here, like the person who's like, I totally believe that, but no one's raising their hand. So I accept that. Halfway, not at all. All right, excellent. We'll now move on. Those are my references. I will make my PowerPoint available as well as the disparities document. Questions, we'll get to that in a moment. That's my email address. I will entertain emails from anybody. I am intermittently on Twitter, less so these days. And I have a website called pathologycentral.org, which has all of my videos that Dr. Reddy mentioned, including a fabulous one on P53 and RB, as well as race and medicine. And then I was importuned to show this last slide. So there we have it, and I will take questions. Yes, Dr. Baird.
Thanks very much, Dr. Dove. That was fantastic. I have a sort of a follow-up or a question about sort of nuance of the basic contention that there's absolutely, like, I've heard it said in many different ways, but that there's no genetic or biological consequence or underpinning to race. And one of the things that people do say sometimes, as you pointed out, was that African Americans appear to have Black people in this country tend to have, what was, did you say 15%, 16%? Yeah. Yeah, so that just means that there's some admixture, but it's not binary, obviously. You can't tell someone apart. But there's still 85%, that isn't. I'm just wondering, is the idea that unless it's a perfect correlation, because there are definitely genetic differences of groups of people, and you're using the term ancestry.
Ancestry is also very problematic.
I know.
In the NASM publication, they do not, because as Cooper says, there's very little concordance by continent. And so they actually, in the NASM publication, they recommend using something called genetic similarity. And it's beautiful, and they're talking about using a term which you actually heard at the USCAP talk with Dr. Wachik, where we talked about hyphen-like. So you look at something like the 1,000 genomes database, and you say it is most like the Yoruba, or, so there are ways that you tease that out. But yes, so genetic ancestry is also problematic.
What I'm getting at is, how helpful or predictive does something need to be for us to use it in medicine? Because we teach Bayesian reasoning for diagnostics, which is start with the pretest probability and then use that to help you get to your post-test probability. So what predictive power does something have to have, or for us to use it as pretest probability? Because isn't Bayes' theorem all essentially just an exercise in formalizing bias?
So first of all, I'm very happy to say I'm not a statistician. So I can't go into the Bayesian stuff. But I will say, as I talked with the residents, we're not saying that the incidence of the 8-year-old girl with cystic fibrosis who was African American. We're not saying the first time that little kid shows up with cough and fever, you're like, oh, could be cystic fibrosis. Let's test it, and we'll do a full sequencing. We'll figure this out. We're not saying the second time that kid shows up, you're like, oh, okay, this is what we need to do. We're saying, by the third time, give it some thought. So what we do at Duke, many of the medical students are familiar with a mnemonic for differential diagnosis called Vindicate. Does the faculty ever heard of that one? Where it's like, you're teaching a student how to come up with the differential diagnosis. You want to be systematic. V is vascular, I is infectious, N is neoplastic, so they can go through. We add a D to the end, so it's vindicated. And that D stands for disparate, diverse population. And the idea is, once you've come up with your beautiful differential diagnosis, you pause for a moment and you say, is there something I would consider if this person were a different race or ethnicity, or came from wealth as opposed to poverty, or was urban instead of rural? Just to think about it. Put that in your note. And then the next time that kid comes in with something, you're like, well, if this had been a white kid, I probably would have thought of that, but it's still unlikely, low probability. The third time, we're sequencing that kid. We're going to find it. Because we can't, we don't have infinite resources. We cannot, you see this, when I was diagnosed with autoimmune hepatitis, because I had Vinay Kumar on my side, we ordered like 50 laboratory tests, right? Everything, copper, iron, everything, right? We can't do that for every person. So you have to play the odds, but you want to be sure that you're not stacking the deck. Yes?
So what do you think the value is of some database like Nomad?
I'm not familiar with the Nomad database.
Basically looks at the allele frequencies among different populations. And so the question I guess I have, it begs the question of how do they assign the populations that they're assigning these variants to?
Right, so we are fine with populations, okay? You need to specify what your population is. But we are fine with populations because we do know that, there was a fantastic study that was done in Nature Genetics looking at South Asia. And they took 260 small groups that were isolated in some way by caste or language or geography. And they looked, they did a molecular analysis to see what their loss of heterozygosity was like, so how inbred each population was. Of those 260 groups, 81 of them had a more significant loss of heterozygosity than you see in the Finns, which are classically a population bottleneck, or in the Ashkenazim, okay? So what this tells you is that when we look at populations, we look at that, you have to be very specific. So there's a group in India called the Visya. And they have a very high incidence of a deficiency in an enzyme that is used to break down a common anesthetic. So if you're an anesthesiologist in India, you don't say to the guy in front of you, are you Asian? You don't say, are you Indian? You say, are you Visya? And you go and say, how about your family? Does anyone in your family had any problem with anesthesia? Which anesthesiologists do, for the most part. So you have to be very careful in how you specify. And what they talk about in the NASM publication as well is the importance, and this is very challenging, of community outreach. This is what we're going to do. This is why we're doing it. This is what population descriptors would you use for your group? And it's a back and forth thing. And yes, it's a lot of work, and we'd much rather just pull up the electronic medical record and say, oh, this person said he was white. Off we go. Just as an aside, I also have challenges with biorepository material, and I've talked with the southeastern group of the NIH biorepository group, sending in a little form saying, hey, I need 50 African-American prostate cancers and 50 white prostate cancers. This is enormously problematic, and so we really need to do more genomic looking at that, along with what the NASM publication says about genetic similarity. Yes.
Even when I'm doing studies, I'm trying to get right representation of each groups. If you still go to a biobank, it's still not representative. You know what I mean?
Right. And I'm sorry, Zoom people, I should have been repeating the question, but I didn't. Dr. Reddy was saying that she's trying to get good representation, but even when you go to the biobank, it's really challenging. So this is one of the things that they talk about in the NASM publication, is that the NIH wants you to put down that socially defined race, right? And there's a very good reason. It was with the 1993 NIH Revitalization Act, prior to that, almost all clinical trials were done in white people, and almost 90% of them were men. Okay, why is this? You had army bases where you had all of these primarily white young dudes. You could go and you could do your studies. Who has the time and ability to go to take part in a clinical trial? Who has access to care? So the NIH Revitalization Act said, hey, you need to include women. That was the first thing. I mean, it was obvious even to the people in charge that there are biological differences between men and women. It was a hard sell, but they did figure it out. At the same time, the Congressional Black Caucus said, well, what about minorities? Everyone's white. We can't do that. So they added, you have to include women and minorities. Now, women, female, so we're not going with gender issues. We say what they meant was biological female, is a biological category, whereas minority or socially defined race is a social category, and that's part of the conflation. Now, we need to continue to use socially defined race in our public health, right? So we can determine which groups are not getting vaccinated, which have a higher risk of a particular disease. We need to address that. But when we do our study, we don't need to analyze those data and report the data by race. And the NASM publication says, don't do it. Now, why? I mean, because it is so hard. I mean, it's almost like, you know, you're out there picking blueberries and there's one really big fat one. You're like, I gotta get that one. Because when you do your research and you look at socially defined race, you will find biological differences because of exposure to toxins, because of increased cortisol levels due to endemic systemic racism. And when you see that difference, and oh my gosh, it's statistically significant, I can publish this. And they say, you know what? Just don't do it because you're reifying race and you are biologizing race and you're contributing to bad science. So if your biorepository is not representative or is lacking, that is due in part to the very real and very valid mistrust that some populations have of medicine, and very rightly so. And you know, I've been working with Dr. Haspel looking at blood transfusion and blood donation. It's so problematic with the Tuskegee U.S. Public Health Service syphilis study, with other things that have happened. There's so much mistrust. So rather than to say, you know, it's really hard, this is where we have to do the work of what can we do, what outreach do we do, what educational activities can we do, and part of that is having representation. So if tall white guy comes in and says to, you know, African-American woman, hey, and we'd like to, you know, take this and do this with it, is that going to be as comforting as an African-American physician saying, hey, let me explain what this is and why we want to do it? We're also impeded, of course, by the medical industrial complex, because if you've got 15 minutes to see someone or you're working very quickly, you can't sit down and say, I understand you. Can you tell me what your misgivings are? Let me respond to that. Let me try to help you with that. You know how it goes when they, you know, sign the informed consent, it's blah, 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 bye. So it's a systemic problem that we as individuals and as a group need to work to solve. And it can be done through collaboration with other institutions, because I know that the ethno-racial distribution in Washington State is very different from North Carolina. So I encourage collaborations, but also careful documentation of those areas as well. Yes?
Yeah, thank you for a very interesting talk. There are guidelines that are changing, and I think many of us are proud to say that for renal function, this institution, and for AFP and prenatal risk, this institution has actually been among the leaders. But there are issues for guidelines that are race-based or geographic origin. And I'm thinking, for example, for allopurinol hypersensitivity.
Yep.
HLA associations are clearly the link.
Yep.
Should we be doing HLA typing for everybody? Do we use race as a surrogate? What's the right answer when we want to be basically, you know, stewards of the laboratory, but also taking care of our patients?
So this actually is particularly relevant to me because my mother is Chinese and she has gout. And so she called me in a panic saying, Asians can have this severe hypersensitivity reaction. I'm like, Mom, you've been on this for 5 years. It happens in the first 6 to 9 weeks, you're fine. But she still got tested because she's my mother. Yeah, right. What do you know? It's not like you're a doctor. Well, yeah. So this came up in my discussion with Dr. Baird at USCAP, which is ideally what we do is we have the resources and we do the testing, because otherwise you can miss people, right? So if I show up and I need to, at some point I may get gout, so I'm eating as many oysters as I can now. If someone looks at me, most people in North Carolina are not going to pick up that I'm Asian, right? And if I don't volunteer that or I don't know about this, I'm not going to get tested. So again, I think gout can be hereditary. Thanks, Mom. So ask about family history, ask about medications they've taken. And yes, I do think, when we talk about blood transfusion, it gets really complicated because, and this is what Dr. Baird brought up at USCAP, is that, we can't, do a full genotype on all this blood, and I need, Duffy null now, and I've got 10 units from black donors, and if I look at that, I've got a better chance. But we have to, it's not that we don't have the money, it's that we choose not to use the money for that. And the reason we choose not to use the money for that is because of who it benefits. And so we have to look very carefully. That's why there's actually been resistance to moving away from race-based algorithms. Part of it is the fear of unknown consequences. If we drop this, what will happen? But the other is who benefits from the way they are now? I would say largely the people who are in charge. So I'm not an absolutist. I'm aspirational. And I do think that we do need to be aware that we're going to miss people, and we need to have a scientific approach to how we determine whether someone's at risk for something or not, as opposed to, oh, Asian, that's what they got. It was absolutely my pleasure. Thank you for inviting me.